Now I'm going to talk about the correct way or the right way to solve quadratic inequalities. Let's go back to the original form, which is quadratic, ax squared plus bx plus c. Then notice that I put in comparison with 0 on the other side. Okay, y must be 0. I will explain in a while. Okay, and the most convenient way and the one that we advocate in this chapter and from the textbook as well is using graphical approach. So all the misconception that you saw earlier in the previous video actually stem from an attempt to solve it algebraically or theoretically without grounding on the graph. So ladies, that is not possible most of the time. Okay? Sometimes you can do that given that your understanding of the method is very clear. You have the mental image of the graph in your head. You've been using it very often. So it's like you don't need to refer to the GPS when you are driving if you already rehearsed the way many times. So the way or the map become part of your mental image. Same thing here. You can do that if the graph has become part of the mental image. If not, we need to follow the step by step. We take the baby step, always draw the graph, visualize it until it becomes part of you naturally. Okay? So first of all, we need to draw the graph. What graph? The graph that is on the left-hand side, which is the graph y equals to ax squared plus bx plus c. Okay? Then go back to the basic. You need to infer the shape. The shape can be inferred from the a, coefficient of x squared. Okay? Then what we need next? We need the x-intercepts, if any. And to do that, I need to solve the equation y equals to 0. Therefore, now you can see the relationship between comparing with 0 here. Because y equals to 0 refer to the x-axis. That's why solving equation y equals to 0 or solving ax squared plus bx plus c equals to 0 is the same as finding the x-intercepts. When there is no solution, meaning this equation or this curve has no x-intercepts. All right? Then after we are able to draw the graph, let's say, then we can compare with the x-axis here. All right? Then we can read off the interval from the relationship that we want the curve to be greater than 0, right? Meaning it will be above the x-axis. Okay? Which one is above? Is the part of the graph that is above the x-axis, which is here. The one that I shade in blue here. Okay? Then x refer to this horizontal line, right? So the solution for x will be if you read all the x related to this blue line. Okay? So I will shade in blue again, which is here and here. Okay? So from this point to the left and from this point to the right. That's the value of x that satisfies the inequalities. That's the step. Always draw the graph. I'll give you an example by doing Q&E2 question 1. Notice that you are given an inequality 3x times 2x minus 1 is less than 4x minus 2. Okay? Now, before we approach drawing the graph, the very first step is to make one side equals to 0 first, right? So if I multiply the left-hand side, I get 6x squared minus 3x less than 4x minus 2. Then I make the right-hand side equals 0. Only when we make it equal 0, we can compare with the x-axis. Okay? And this is the curve because I get 6x squared minus 7x plus 2 less than 0. Now, notice that I can actually factorize 3x minus 2 and then 2x minus 1 less than 0. When you do this, hold on, okay? Don't assume 3x minus 2 less than 0 or 2x minus 1 less than 0. That's not the case. All right. What we need to pay attention to now is find the shape and the x-intercepts. Okay. So the shape of the graph would be upwards, right? Because of the coefficient here is positive. The shape is upwards. So now I want to find the intercepts. So when intercept happen, when 3x minus 2 times 2x minus 1 equals 0. Notice the words when. Okay. So in my working, if I want to write that, I will put when because I want to make it clear that I'm finding the x-intercept. So the 2/3 or half here basically are the two x-intercepts. Okay, that's why there's a context of when, because this is not the continuation of this step. This one is a separate step that the intent is to find the intercepts, these intercepts. Okay, so let me draw the graph a bit bigger. Okay, the graph will be like that. Then this is x-axis, and half is over here because smaller than 2/3, and 2/3 is over there. All right. Now, we want it to be less than 0. The meaning of less than 0 is actually below the x-axis. Which part below x-axis is actually here? The one that I shade in green. This is the part when the curve is below the x-axis. So, the corresponding x will be here, right? From here to here, from half until 2/3. So, x will be between half and 2/3. Sorry, this should be half and 2/3. That's the step of solving quadratic inequalities. Okay, so in other words, every time you see inequalities, don't jump. Okay, always think about the graph. Sketch the graph, compare with the x-axis, and then read the interval. Okay, I'll give you one more example. For example, in the question A1 part 2, you are given x plus 2 squared bigger than 9. Okay, so don't rush into coming to here x plus 2 bigger than plus minus square root of 9. This is totally wrong. This is the misconception that I highlighted earlier. Okay, so in that case, how? Just go back to the basic. Make one side of the equation, sorry, one side of the inequality to be 0 first. Okay, then I can solve this, right? I can actually work on this curve. How to do it? Of course, the basic thing is you can expand x squared plus 4x plus 4 minus 9 bigger than 0. Okay, so you get x squared plus 4x minus 5 bigger than 0, right? So you will get x plus 5, x minus 1 bigger than 0. What's the next step? Shape, right? The shape coefficient of x squared is positive, so the shape will be like that. Then I just need to find the x-intercept. Now, if you are fast, right, let me redraw over here. If you are fast, I don't need to write the when x plus 5, x minus 1 equals 0. I can just straight away infer this will be negative 5, this will be 1. That's perfectly fine. Okay, because the idea of the step of writing when x plus 5, x minus 1 equals 0 is just to find the x-intercept. But if you can identify x-intercept immediately, you don't need to spend extra time to write it down. Okay, so now the next step is I want the case when it is bigger than 0, which means compared to the y equals to 0, it has to be above. Where is it? Actually from here onwards. Okay, and then from here onwards. Yeah, I put a hollow over there because like it doesn't include the negative 5 or 1. Okay, slightly above those. So what's the x? The x is very easy. You just look at this corresponding region, okay, and then here, right? So that's the x correspond to all the values of y that we shade in red. Okay, so the solution will be x less than negative 5 or x bigger than 1. Got it? So that's the step of solving quadratic inequalities.